And Florida kind of hits both of them, right? Like where archaeological sites preserve really well and where they get destroyed really actively. So archaeologists, especially for me, working in the earliest peopling of the New World, have a few different issues that we've been working on for a really long time trying to figure out, right? We've been trying to figure out when did people get here and where did they come from? And then once they're here, how did they live, right? And so we've been trying for years and years to answer those things. And right now, our best information indicates that people got here during the terminal Pleistocene, which is the latest part of the last ice age. It's about 21,000 to around 11,500 years ago. And you guys have already seen a bunch of wiggle charts in the last talk, but these are just some different ones talking about basically what you're supposed to pay attention to is there's some kind of concentrated wiggles and then a big jump and then some more concentrated wiggles, right? The top two things are hydrogen isotope data and oxygen isotope data from ice cores, and then the bottom one is a sea level chart for the Gulf of Mexico. And these first people who came into the New World were known as Paleo-Indians, or are known as Paleo-Indian to archaeologists, and this is just a term that refers to the Pleistocene cultures in America, right? These are the people who are adapted to these ice age environments, and at the end of the ice age, there's some major cultural changes that occur that go along with the major climatic changes. So we've been trying to figure out how all those things work together for a long time. So this red line here is about when we think people got to the Americas. So you can basically see from that red line this way is kind of the cultural history of the New World, right? And like the major environmental changes that are occurring and so on and so forth. So to start off with, there's a couple kind of basic archaeology terms I'm going to give you. First of all, archaeological sites are where we get our data from, right? And it's an important thing to say, there's a couple of things that are important about this. So any place on a landscape where people do things is just a place on a landscape where people do things. It's only an archaeological site if they leave tangible evidence of their doing those things, right? And if that tangible evidence survives until archaeologists look for it. So there's two aspects to that. And that's really important because as soon as people leave a site, nature begins to take its toll on the site, right? So a lot of times people do all kinds of stuff on the landscape, but the evidence of that stuff gets destroyed almost as soon as people leave it, because a lot of material culture of various peoples is organic. It's made of cotton, it's made of meat, it's bone, it's all of those sorts of things. And so bacteria starts to break them down, the sun and rain starts to break them down, and usually what we as archaeologists find is just the inorganic remains of whatever people left behind. So if they didn't leave any inorganic remains, any stone, any metal, anything like that, we don't find them. And the things that they did leave behind that do preserve from being eaten by bacteria or other animals get moved around by the wind, they get buried and unburied, they get picked up by other people, all kinds of things, trees fall over and pull them around, all kinds of things happen to them. But occasionally we have sites that do preserve organic remains because bacteria need warmth, oxygen, and water to cause decomposition. So if you get a site that's buried really quickly or drowned really quickly, you can have low oxygen levels, or you can have enough moisture that it never dries out, or you can have things that stay cold enough that bacteria never form and never eat up those organics. So it's important to remember that sites are created by a combination of cultural and natural processes. People do stuff, and that's a cultural thing. The natural processes happen and say what survives and what doesn't. So despite the fact that archaeologists have been trying to understand when and how people got to the New World and how long they've been here and how they've been living, we've been doing this for a number of years, and we still haven't figured it out. And it's not just because we're really bad at our jobs. It's because a lot of things have happened to change the world since the end of the last ice age. So you'll see here this little chart, for those of you who can read it. It says 18,000 years before present. That's 18,000 radiocarbon years before present. That's actually 21,000 real years before present. Not that I'm going to make you guys learn about radiocarbon calibration, but basically just know that there's some variation in the dates based on what dating methods you use. So during the period from 21,000 years ago to 11,500 years ago, there were some major environmental changes occurring, both in tempo and intensity, way stronger than anything any of us have seen and living through, though maybe we're facing in the next few years based on the last talk. Basically, it was a world that had all kinds of big animals we don't have now. It was a world in which there were humongous glaciers that covered the entire North Pole and some of the South Pole, basically all of Canada. And because of the amount of the world that was tied up in sea ice, sea levels were much, much lower. So that kind of lightish blue over here is where the ocean level and Florida was 21,000 years ago. So the entire continental shelf of Florida was exposed. Florida was more than twice as big as it is now, 21,000 years ago. And as the glaciers melted and everything was drowned, the world changed really, really quickly. Now, I found this on the internet, but I think it's this great demonstration. The ice sheets 21,000 years ago were so thick that these are modern cities and they're modern skylines and showing exactly how much ice was over them, right? So Montreal had 3,300 meters of ice on top of it. Chicago had 900 meters of ice on top of it. Meters. So, you know, more than a mile's worth of ice in some places. And that is a huge amount of water to be tied up in on the land and then to be really quickly, within 10,000 years, melted and brought into the oceans and changed a lot of things. Oh, apparently I had PowerPoint problems today too. So that brings us to why Florida. Why is Florida a good place to look for the evidence of the first Americans, right? And Florida is a good place because, remember, I told you organic materials can preserve really well in certain conditions when you have low oxygen and when things get wet and stay wet. Florida is the only place in North America for the terminal Pleistocene where those conditions are regularly found. So although none of our models for where the first Americans came from start in Florida, we think they came through Alaska or maybe through the kind of northern part of the mid-Atlantic, probably through Alaska. We do think that these sites can tell us a lot. You see all of these red dots here. Those are Paleo-Indian sites in the state of Florida. Florida has more Paleo-Indian sites recorded than most other states by far. And part of that is because more than half of those are sites that are found in sinkholes in the state of Florida. And because of our geological terrain, our karst environment in which we have limestone with these holes in it that work as sediment traps, that work as really nice places to hold water, they preserve these archaeological sites really well. And they don't preserve anywhere else. Now, this picture right here, where did it come from? There you go. This is the Osceola River, which is where I work. It's about 40 miles away from here. And you see all those red dots, those are Paleo-Indian sites in the Osceola River. And they're all in the river. All of them are underwater sites. There are more. There are about 35 of them. There are more in that one chunk of that one river than there are in most other states in the United States because of preservation. We don't think it's that there were all the Paleo-Indians got to Florida and built their high-rises. We think it's that this was probably the situation for most places. And it's just that they preserved really well. So a big research question that I and my colleagues over the years have had then is, are these things in the underwater sites in Florida because, are they in these sinkholes? Is it stuff that's just washed in? Or is it the remains of past human activities, right? Like, is it just stone tools that get washed in the bottom and they stay there? Or is it that when sea levels were lower, the water levels in these sinkholes were lower and people were living and working in the bottom of the sinkholes, and then as sea levels rose and the water levels in the sinks rose, everything got drowned and buried, right? Which is the case. So we've been doing research in this sink. I started working here in about 2007 when I was starting my dissertation research, and I've been working there every summer since. We've been doing a lot of different research in the Osceola in these sinks and digging. You can see here, this is us digging through sediments at the Page-Ladson site. This is well-preserved elephant dung. There's no better way to put it. It's from extinct mastodons. Apparently mastodons really like to eat grapes and squash. There's a lot of gourd seeds and a lot of grape skins in there. This is us measuring and looking, and we're trying to figure out, do we have cultural material that is in these layers, or is it all churned up, and therefore we have to pay really close attention to the geological context from which we recover things. So in 2013, we found that stone tool fragment right there laying in one of these layers, which turned out to be super important because that stone tool, when we dated the materials that were around it, and that's a close-up picture there with my dissertation advisor being really chipper. He's not a diver, so he was really excited that we were able to bring stuff up to him. So we excavated these areas in red on this site. We found that. We also found the remains of several extinct animals, 2 mastodons, bison, horse, paleolama, some other stuff in our layers. And we were also able to do some really good drawings, well, not making them up, but we were able to do stratigraphic profiles and take a bunch of radiocarbon dates. And what we found was that that one biface, that stone tool I just showed you the picture of, with a whole bunch of radiocarbon dates around it, dates to 14,500 years ago, which is about 1,200 years older or to 1,400 years older than anybody else thought previously people had been in the southeastern United States. But we're pretty sure about those dates. We're able to date it a whole bunch of different ways. We're pretty sure about the secure geological context of it. So that site shows us that some of these sites are preserved places where people were living and working and doing some things. And we figured out also from a bunch of proxy records, which I'm not going to go into what we did, but we analyzed the sediments from those layers 6 ways to Sunday. And what we figured out is that at the time Page Ladson was occupied, it was an open, drier savanna around it. And these sinkhole ponds would have been isolated water holes. The rivers would not have been flowing when the sea levels were that much lower. The aquifer levels would have also been lower, but they would have had springs bubbling up in them. They would have been good sources of fresh water. So they would have been sort of like oases. People and elephants and camels and horses and all those things would come to drink. And if you were a smart hunter, you could go to find your local elephants to kill, butcher, eat in those areas. So we think that these folks at Page Ladson were inland foragers, and that they were hunters and gatherers that lived, you know, in the kind of open savanna areas that we're in. Now, it's really interesting because our proxy records are a little bit contradictory for Page Ladson. The pollen records show that it's really open, but a lot of our diatoms and things like that show that it was probably a decent amount of rainfall. So usually you think there's a lot of trees when there's a lot of rain in places like Florida. What we think might be happening is there are both mastodons and mammoths on the landscape, and mammoths are large herd animals, and they're sort of like modern African elephants in a lot of ways, like we think based on what they do. And modern African elephants create prairies out of forests. They are big earth-moving animals. They tear things up. So we think that the climate may not have actually been that different during most of the late Pleistocene, but that the mammoths on the landscape were really opening things up around these water holes and turning not prairie into prairie, kind of, or savanna, these sorts of environments. This isn't something we're for sure on right now, but I have a doctoral student who's doing some analysis of these things, trying to figure that question out a little bit more. So what does Page Ladson tell you? Page Ladson is a place where we have good opportunities because of the preservation of Florida. People were in Florida more than 1,400 years earlier than we thought. And this little inland, not exciting, not abnormal, not standout place in the middle of the savannah, in the middle of nowhere, shows that probably people were occupying most of the interior and upland portions of the continent by this time. That people were really well distributed on the landscape. And we only know this because we found that stone tool in that layer of mastodon dung, so we could radiocarbon date excuse the pejorative, the crap out of it, right? Literally in this particular case, right? So we could say this is what happened. If we had found that stone tool in any other site where there's not good organic preservation, where we can't directly date it, it isn't that interesting. It's just a stone tool, just one little fragment. So that kind of was one of the really big opportunities. So what's the less good part about Florida for archaeological stuff, right? So remember, our sites have to have evidence of human activity that survives until archaeologists find it. So the coastal sites in Florida, and there's a lot of them, are in trouble, right? And there's been a lot of sea level rise, as I showed you, and during the 21,000 years ago, sea levels were about 130 meters lower than present. When the first people got here, that little blue box right there shows you the first people got here, sea level was about 100 meters lower than present. And around 4,500 years ago, sea level got to pretty much where it is now. If sea level rises 1 more meter, and this is one from the NOAA website, we will have a lot more of Florida that goes underwater. So just to put it into scale, when Page Ladson was occupied, that's where sea level was. And so that let us, that's way out past the Florida middle grounds. It's about 100 miles offshore where it currently is. That was all dry land when the Page Ladson folks were living there. Most of the Gulf of Mexico was dry land for them to live on, work on, hunt on, do whatever their lifeways were on. But as the sea level rose during from 16,000 years ago to 5,000 years ago, that 10,000 years, that 100 meters of sea level rise, many, many, many sites would have been drowned. And today, just to put it in a scale, these are the archaeological sites that are recorded for the time period from 15,000 years ago to 5,000 years ago on the current landscape in Florida. If sea level rises 1 more meter, a whole bunch more of those sites are going to go underwater. And this is problematic because coastlines are very dynamic, destructive things for archaeological sites and, fancy coastal villages and all of those sorts of things as well. But of course, what I care about is the archaeology, not the modern people, right? And so that can be a really big problem because it can really rework sites. It can destroy archaeological context. And context is something that is super important for all archaeologists. If I found this stone knife hanging out right here on the ground, what does it tell me? At one point in time, somebody made a stone knife. Awesome. That's basically the sum total of what I can know about it. But if I find it in a stratigraphic profile that I can radiocarbon date above, below, and around it, I can say 14,500 years ago somebody made a stone knife. And to you guys, that probably seems esoterically not that different. But it changes our complete understanding of what people are doing and when in the southeastern United States. Versus, if we have all these surface materials, and these are a projectile point style that's been found rarely, but all over Florida. And these, some people have said, are approximately 14,000 years old, maybe 16,000 years old, maybe 18,000 years old. People have presented all kinds of possibilities for how old they are. But they have every single one of them, been found hanging out in the bottom of the sinkhole loose or on the ground loose. And we've never been able to date them. So we don't know how old they are. And all we know about them is somebody made them at some point in time. We don't even really know what they were used for. And so people have made these recreations of time, and this is those points right down there, saying these are the oldest projectile points in the state of Florida, the oldest spear points. But we don't actually know that. We just think that. So finding things loose is really bad for archaeologists. We can't talk a lot about what cultural choices people were making, what people were doing. We just say somebody shaped a stone tool. So is things being loose, though, is an important question. And some of my research has shown, okay, remember I told you one of my initial questions was, does being drowned ruin all the context, mess up the site so that everything's just loose and that's all it tells us? Well, at some younger sites, these are about 10,000 years old, so just on the other side into the earliest Holocene, there's all of these layers where there's these intact soils that were surface areas that people were living and working on, and then sea levels rose more and drowned those, and they're now all about 16 feet underwater in the rivers. right? So they're really well preserved, about 16 feet underwater. So not buried, at the time, like found in the sinkholes, probably doesn't mean they have no context. They're probably trapped in the sinkholes from which people originally deposited stuff. And being offshore doesn't mean everything's lost. There was a former professor that used to be here, Mike Fott, who did some research off the offshore part of the Osceola River. And in his few years of kind of limited investigations out there, they found about 30 sites from the same time period in the Osceola River mouth where you can see the channel running underneath the current ocean. There's a lot of sand on the surface, but you can use some remote sensing gear, and they found artifacts that are the same styles as the ones we're finding on land. So not surprisingly, when it was all land, people were moving back and forth on all of the land using it. When it became underwater, however, and this is right there is where those came from, when these all got drowned, a lot of these sites probably were destroyed. Probably a lot of them were reworked by coastal processes, but a few of them have survived, and there's some really interesting time periods during which sea level rise went in the course of a decade or 2 decades or 5 decades over several meters high, which means it goes so far inland so fast, nothing stays on the shoreline for very long in places like the Gulf of Mexico, right? That's why 1 meter of sea level rise in the Gulf is super catastrophic, because our coastline's so shallow gradient, every little bit of rise goes really far in. So that means things aren't being reworked really well. So that's good for the archaeology, bad for the people who live on the current dry land. So over the next couple of years, though, we're going to keep researching this. So we're going to keep investigating these sinkholes on land, and I also have a master's student who's doing some more stuff trying to get back out to those sites out in the Gulf of Mexico, try to get us a little more investigation of them. Of course, offshore research, as you know, other folks could say, is not exactly cheap, so we're building up the money to do that, and we are making new discoveries, like this elephant bone right there. You see how it's half black, half white? The white part was just exposed to the water column within the last probably a couple of years, or else it would have been stained black as well. So there's a lot of stuff there that's still left to be found that we're just starting to understand. And so hopefully we'll be finding some more sites to help us answer these questions and talk about what sites are likely to preserve and which sites are likely to be destroyed with increasing sea levels, and what we might do to have, take care of them. Obviously, these ones in the rivers are fine. They survived the first bit of submergence, the first 100 meters of rise. More rise didn't do anything to them. But the ones that are currently on dry land as sea level rises, they're probably going to have the same difficulties as, your fancy boathouse. So we have to figure out what to do about those sorts of things. So I've had a lot of people help me with this research, and, a lot of people help me personally and with funding, equipment, site access, things like that. Any questions?
We've got about 10 minutes for Q&A.
So a question about the point that you found in the elephant dung. Is your thought that that was just tossed it in, or dropped it, or wading through, or was it?
So what we think was going on there is, so there's 2 mastodons down there, and one of them has a lot of evidence that it was butchered, and the other one, we don't have a lot of the bones, so it may well have been butchered, and they took the bones of the parts that they were interested out. But what we think was going on is people were cutting apart a mastodon on the edges of a pond, like right on the edges of it, and either that knife snapped in half, which it did, so either it snapped in half and they're like, and dropped it and kept going on with a new one, or something like they left it behind as they were going, or something like that, along with all of the remains of the elephant parts that they didn't want. Yeah.
In the North Sea, there's been a fair amount of remote sensing done in water, sometimes, I guess, in coordination with BP and with oil exploration, Vince Gaffney and others. Is there anything comparable that's been done for Gulf sites?
Yeah, so the same thing, the same laws are actually different laws. In the U.S., the Bureau of Ocean and Energy Management oversees all hydrocarbon production in the Gulf of Mexico and in all of U.S. waters, right? And so when they're doing their, like when BP wants to develop a well or something like that, they do have to have archaeologists out there, and they are doing remote sensing survey. However, with almost all oil production, the rule is if you think it might be impacted, you move to somewhere else, like you lay your pipeline over here instead of over here. So there's been a lot of survey, but like almost all that survey data, it's proprietary to BP and Shell and all of those folks. So BOEM sort of has access to it, but at the same time, they can't just give it to archaeologists or anything like that because BP owns it, right? And so, and it's obviously not super in their interest for everybody to know exactly where all the sites are. And mostly they don't know their sites. It's that the archaeologist that works for them says, this could be a shipwreck, or this could be a really good place to find one of these inundated terrestrial sites. And they're like, oh, well, what about over there? No, that doesn't look good. Well, let's put our pipeline there. So they're not actually impacting the sites either. So it's not like they're hurting anything. It's just that they're not going to just give away things either. So
the knowledge of these sites, terrestrial or other submerged terrestrial sites, these sites aren't being published or
not so many of them. The ones, those two pictures I showed you, Mike Fott did publish a lot of his stuff, and he's done a lot of stuff. It's just, I mean, you know how expensive it is to work offshore. So it's, archaeologists get out there for a couple of weeks at a time, and it's our couple $100,000 grants. We get to do a little bit and say there's really good potential here. This is awesome. Well, we need to get back out here, and then next few years you get another couple $100,000. You do a little bit more, and so on and so forth. So it just takes so much longer to do that research than land research. So like the NSF, they would rather fund. They only get for archaeology a couple $1 million a year. They would rather fund 50 terrestrial projects than all that money on one underwater project, and you can't blame them at all.
Thanks.
Mm-hmm.
This is, I guess, more of a point of clarification. You could explain about the people who live in the sinkholes, and so like maybe
yeah. So it wasn't like they were. It was more like, so have you seen sinkholes? Have you seen dry sinkholes and how they often have like a steep side and they often have like a slopey side? Well, they have water in the bottom, but not all the way up to the top, right? So a lot of these are sinkholes in the literal sense, but they'll sometimes run for a quarter of a mile long or a half mile long of like, it's almost like a little river valley. And there will be deeper bits in it. So it wasn't that people were living just in the sinkhole, it's that they were using the land all around it and down all the way to the water's edge. And when the water's edge was 30 feet lower than it is now, then the sinkhole was a smaller pond in the bottom. And then when the water was, 10 feet higher than that, there was still an edge, and they would use to that edge. And then when it got up to 30 feet up, it's where it is now, and all of that's underwater from before. Yeah.
In the way that the rising ocean levels impact the actual freshwater aquifers in Florida, and that with these modern context, I think these water wars, people use having to tap on the aquifers that much more. Do you think there's any implication for affecting general hydrogeology?
Yes. So the hydrogeology of karst environments is incredibly complex. It's not like in a lot of non-carbonate system states where water level all comes up and all goes down at the same time. In a place like Florida or other places that are on a dissected limestone shelf, there will be freshwater pockets way up here and then saltwater pockets here and then freshwater pockets here, and it's not like a straight up linear relationship because the water doesn't just percolate up and down equally. It kind of moves through the aquifer at different places, which is totally not my specialty, but there are folks in this state of Florida and a bunch of folks that work at the Florida Geological Survey who pay attention to exactly that, and they do a lot of dye tracer studies and stuff to see what is connected to what and how everything's impacted. And yeah, there's huge impacts. Obviously, as sea level comes up, the freshwater will usually perch, in there, and sometimes it'll be weird because there'll be hypersaline parts that'll be way lighter, and then so it'll be weird gradients of where the fresh water is in an aquifer, and sometimes it's on top, sometimes it's on the bottom. It's all kinds of things that seem like they're going against the laws of physics until you understand what laws of physics are ruling those. Do you have a question back there?
I have a question about something that may or may not interest you.
Around 1990, my diving partner and I brought back from Paradise Springs, south of Ocala, some speleothems that were hanging from the roof at about 140 feet. And we gave them to J.K. Osmond in the geology department. He analyzed them and he gave us a report back saying they were 80,000 years old.
Okay.
So we know that that place was dry at that time. How many fluctuations it underwent, who knows? But I don't know whether it would be of interest to you to go back to that place and look and see if you can find pockets that are shallower or more.
Yeah, maybe. And in fact, I have a PhD student who is at Texas A&M who is a cave diver from this area. He grew up in Jefferson County, so he would probably even be more interesting to go, back into those caves and do some research on that sort of stuff.
Well,
I don't really.
Last time I was there, the owner was named Jimmy Paradiso, and I don't know whether that's the person that owns it anymore, but.
That'd be an easy name to trace, probably, though.
Any other questions? Okay, if you just want to hang around for a few more minutes, we're going to have closing remarks from the Associate Dean of Research and Learning Services, Mr. Mike Metheny.
Sorry to be juggling through here with my video, but
5 more minutes and we're all done. Yes, that was the last speaker. That was the last speaker, yes. I'm just going to give some quick review. In a minute, is that okay? Yeah. Thank you. That's a great question. I'll be somewhere over here. That's okay. All right, my name is Michael Meth. I'm the Associate Dean for Research and Learning Services here at the Florida State University Libraries. And I just wanted to quickly say how amazing it is for me. We do these symposia every half year or so. And it's always amazing how an idea is presented to me as a topical thing. And then I say, sure, that sounds great. Let's see what we come up with. And then amazingly, we pull together this incredible range of speakers and topics, and all this research that happens in our university is just astounding to me. And just this interdisciplinary symposium that we can put on just blows me away. So this was, to me, was just a phenomenal journey. How we started with Jose Mendoza Cortez this morning, who kind of showed us the future, right? He really took us out somewhere else with like hydrogen and how that will power us and energy. And then Chris Uejo brought us right back to Earth and talked about Flint and some of the crises that we have there with water right now. We then went with Juan Carlos Galeano over to Latin America and looked at the Amazon River and the spirituality around the river and the system there. And then we came right back to Florida and, well, Georgia and Alabama too, with the Archaeological River and Katie McCormick talking about the river keepers there. In the afternoon, we listened to Chris Harper talk to us about rain, and it was a very insightful and humorous look at what is perhaps a really controversial and problematic history of the United States of America. I'm just going to say that. And then somehow Jeremy took us like right back into 4.5 billion years ago into like ancient times. And then Jessi brought us back forward a little bit into the future, not all the way though. Although I have to say, like, some of these coastline pictures were a little bit devastating. So a few things as I listened to today, I thought, words that came to my mind, and I'm just gonna throw out a list of them. They're just thoughts that came into mind, they're just words. But so everything is prefaced by water is. So water is chemistry, energy, political power, essential, social justice, spiritual, controversial, connection between people, connection between fauna and flora. It's global, it's local, it's past, present, and future. It's vital to our survival and well-being. It's fun, it's life, it's hope, but it's also a lot of despair. Again, that some of that blew me away. So I want to quickly say some words of thanks. I tried to write them down so I don't forget who I have to thank. Let me just open this one up. So first of all, a big thank you to Jessi Klein and Trip. Where are you, Trip? They're both hanging out in the back. They both are the masterminds behind the symposium. I want to thank a whole bunch of other people. So Travis and Chris from our marketing communications unit, who amongst other things helped us set up the whole Facebook live feed. So if you didn't know, but we're live on Facebook. All these talks are archived, recorded. They were live streamed, and then we're actually going to put them into digital, which is our digital archive. Also, a thank you to Steve Aqua from GeoSet, who helped us with the technology and got us set up and figured out how to actually live stream. So this is a totally new thing. Michelle, Nikki, Jasmine, Mackenzie, Ginny, I'm probably forgetting somebody, but there's a whole bunch of folks and our students who helped us just set up. Should we have lunch, coffee, all fed, we're all nourished, and all set up. Of course, a big thank you to all of our distinguished speakers. Those of you in the room, you might be online, and those who have left and are not looking at this right now, but thank you anyway. Thank you to all of our guests who've come and made time online and in person. And I just wanted to, before I ask for any last comments from the audience, and I think I have somebody waiting here to give some, I just wanted to mention this. Chris Harper, right here in the front. If you enjoyed her talk, there will be more of it. Next Friday, if I'm not mistaken, at Newkirk, she'll be doing a faculty reading and book signing. It's called her book, and the research will be presented in perhaps a different format. All right, and you got a signed copy. So I heard somebody else ask earlier if the book's already for sale. So I assume it must be if it's going to be signed.
I hope so.
Chris says she hopes so. I also wanted to remind everybody how Katie McCormick talked this morning about the Archaeological Riverkeeper and how there's a real opportunity to participate in so many different ways on something that is a river that is impacting all of us very, very much. So I wanted to open the floor before we close the symposium, just to see if any of you had perhaps any announcements or any other comments that you wanted to share with this group, maybe their insights or sparks that went off. So it's good. Yes, sir. Do you want to go first?
Yeah.
Okay.
I'm not planning on saying a word this conference.
Okay.
Got something strong to drink?
Sorry?
Got something strong to drink? You got something strong to drink?
Any songs to drink? I'm not
On
sure.
the seating. I need a glass of water.
Oh, he needs a glass of water. Do we have some water, perhaps? I think we have water on that side over here. Did you have a glass for him, or?
Yeah. Oh, I don't know where the water is.
Well, we have water on that side over here. I think Church is
We got
getting
some.
You're going to get some water in a second.
Okay. I'll start with the conclusions and work backwards. I've been working on most recently in the triage Everglades.
Okay.
Do you understand me? Triage of the Everglades. Is it clear? You hear me?
Yeah. Thanks.
Thank you, sir. Thank you. No whiskey?
No whiskey this time? No. That's the after party.
It's almost 5.
You want me to,
Hold that for you.
yeah, there's no
You
wine.
want me to fill them in on what you've been doing?
Come on, you come in.
Why don't you come and speak it tonight?
Yeah.
You capture it quick.
Very recently, I've been studying the triage Everglades. I think I said that already. We got some good dates there. 314 dates. Okay?
Can I back up?
Yeah. Don't do I back up too far.
No, I don't want to back up too far. He's a former professor at FAMU and started the wetland ecology program at FAMU.
That's too far.
That's too far. Anyway, I just wanted you to know where he came from. And okay, Everglades was the first place.
Yeah. Oh, we had some days there, 14 days. Over 4,000 years ago, there were people living on these tree islands.
4,000 years ago? Okay.
Anyway, let's see it. The island was high and dry. You know it's dry because of the petricalcium rising. You know what a petricalcium rising is? The soil dries out on top of it. And make it very short and sweet, I hope. And you got that, we 4,000 years ago, over 4,000 years ago, there were people on this hillocks at that little hills at that time. And we go back to Ozell. You know where Ozell is? A little town below Crystal River.
Ozella, Crystal River.
Well, another date there. Let's see, what, 1400?
1400.
1400 years ago. The sea level was maybe 6 or 8 foot higher than it is now. It was falling at that time. And we found forams there, which we determined to be, there. Forams didn't tell us a date, we did see 14 dates on it. Forams tell us oxygen level, right? Or 18 anyway.
I type his papers, but I don't know anything about this.
I know it well. And then you got Weed Island culture.
Weed Island culture?
On the Silver River, there's a mountain there with a petricalcite rising on it. It's about 1,500 years ago. 1,500 years ago. Yes, that's about it.
Okay.
Awesome.
Well, thank you very much.
Thank you.
It had been published. I thought that Mike Russo or Dr. Williams would be here. You know both of them, I'm sure.
Park Service. Yeah. Okay.
Anyway, I was going to be there to say something intelligent. You got me.
Well, thank you very much for your comments. Appreciate it. Thank you.
You're welcome.
All right. Did anybody else have any comments, announcements, or anything they wanted to share before we close out today's symposium? Yes, Jessi. Jessi, you want to come to the front so we can?
Sure. Yeah. It's a small one. So over here, there's a book display right near the staircase and elevator, and we're going to start dedicating that to a range of interdisciplinary research topics. And right now you'll see a display up there regarding our symposium today, which is on water. And so there's going to be a lot of books, picture books, art, videos, all kinds of things over there dedicated to this topic. So every time you come in, it's going to rotate every 2 or 3 weeks to get to see a new topic and maybe get some good ideas for future research.
Well, with no further comments, thank you everybody again. Meeting adjourned. Symposium adjourned. We'll do it again in the spring.
Yep.
Thank you very much,
Good
everybody.
job, Jessi. Thanks.